Yeah.
Yeah, sure. You have 15 minutes, please.
Okay, we can start. So I'm glad to greet our guests and listeners on our meeting and that conference. And today we are going to present to your attention a report for our research named as Technologies and Services of Communication for Embedded Systems over Internet. Our topic will contain such stages like introduction with preconditions and motivation, goals and objective setting, and factor analysis where gonna be presented basic requirements for IoT development process. Closer to the middle of speech, we will observe and highlight existing hardware components and sort them by classes. Also, there are gonna be described communication processes and protocols. On finish, we want to propose a new communication device model that can be used while IoT development process on first stages and conclude our speech. So let's go on. Uh, for the last decade, a number of embedded solutions used in different sectors of human activity exponentially grew. According to that, scope of application for IoT systems became more various and complex. In that case, appeared a necessity in more detailed description of principles and approaches to IoT solutions. And the issue of approach to connecting devices is included in the group of mandatory considerations. So for that study, the goal is to simplify a creation of programmable devices process and grant user the ability to program such systems over internet. For reaching a assigned goal, there are a few tasks that should be solved. There are analysis of issues for communicate device over internet, the observe and classify existing IoT components. Uh, on example of typical device, describe the communication process and propose the model or approach for description of IoT device communication. According assigned tasks, basic factors which have a significant influence on IoT development process were observed. We can divide them into two main groups: factors of building IoT systems and factors of securing such systems. In building, we can include such factors like implementation and interfaces compatibility difficulties and limitations of the interaction protocols. Also should be noticed that duration of development, system dimensions, and cost are also significant. In one more group of factors, we highlighted security issues. They are represented by safety providing, physical and financial security, cybersecurity, and accessibility. And in the second part of our speech, I'd like to give a word to my mate, Dr. Priblitzin. Please, can you continue?
Yes.
Okay, so you can take a word.
Well, so for the moment, it's possible to focus on the following set of the components developed or possible classification for such services that capable to perform the communication with different components of IoT systems. The first one is completely exclusive solutions or such prototypes developed by the end engineer, and created to prove some concepts and to check is it working, and it can be based or can be created based on some elements and composed from them. The second category that we propose is the standardized model set that are created based on some elements, and that provide an ability to perform the distributed development of groups of teams. For example, one person can be placed at one country, another in different country, and the sharing of the software can be done over internet, but it's possible simultaneously to perform the development of such components using the distributed approach. The sets of components include the well-known Arduino components, but not only. The third type of the IoT components are the mass-produced solutions, and this is the main element of such research and the element of classification of such elements. And this is the ready-to-use solutions that are produced in the general conditions, and they are ready to use with services, sensors, and protocols. Also, additional type of IoT systems are the installation systems that are installed in the entire building, like the infrastructure of the elements, and they are completely dedicated solutions that require some extra maintenance, some specific tools, and they are completely proprietary. And the last type of the IoT systems are the completely exclusive professional devices that include some specific solutions that not provide an ability of some extensions, modifications, and involvement of the users of some development teams. So next slide, please. Based on the research, it's possible to propose the following results of the analysis of the comparison of such types of the components of the communication services based on the following categories, like price, required efforts from the end user to launch it, and the possibility of modification or support of modification. And based on this result, it's possible to see that such devices are sorted by the price, and it's clear. From the point of view of possibility of modification, they are also sorted from the possibility of any modification to the rejected any modifications for the professional devices. And the amount of efforts also is minimal for the devices with higher price. But based on our analysis, it's possible to conclude and propose to use the do-it-yourself models, like the ready-to-use components, and off-the-shelf devices with mass production that are also capable to be connected to popular services, and it's enough to organize and modify it with reasonable price and with reasonable compatibility with existing services. Next slide, please. So, based on the considered ways of communications, it's possible to create the following diagram of the communication with the end services of such components of smart home with use of elements of peripheral elements. controlled over the some main device connected to the internet over internet connection. This device is communicating with services over the internet, and with the same service, the user device can perform the communication, because it's possible to organize the sharing of the data and to perform the monitoring, and so on and so on. Well, and based on this form of representation of such communication, it's possible to find the place of such communication services as some place between the user or between the API of some services that involve to organization of communication with the end device on the one hand, and with some coordinator or main device that performs the communication over peripheral interfaces with the local devices in a smart home on the other hand. Well, please, next slide. The results of analysis shows that the most popular interfaces and protocols include the following protocols. REST, it's both methodology and the communication protocol. MQTT is one of the most popular protocol. It means message queue and telemetry transport. It's some simplified version of TCP/IP protocol, and it's widely used. Just all popular ready-to-use devices provided to users and as sensors with direct connection to the internet support this protocol. Also, this protocol is supported by most of open source services for communication with the devices. Next protocol is XMPP, Extensible Messaging and Presentness Protocol. This protocol is designed to simplify the process of communication with such devices. Another protocol is AMQP. It's also a popular protocol. It is based on the open standard, and this standard is focused on the message queue processing. Another important protocol is the COAP, or Constrained Application Protocol. This is a lightweight HTTP protocol for small devices carried out by 8-bit processors, and they are based on such solutions, and the simplified version of the protocol helps to allow the communication with the services even in the devices with not enough memory of program and small resources of the chip. Also, the services support the traditional or popular protocols like TCP, HTTP, WebSockets, direct socket connection, and so on. Well, next slide, please. So based on the analysis, it's possible to divide all the amount of the services by few groups. The first group is based on the Magic Corporation, the biggest companies like Microsoft, Amazon, Google, IBM, Watson, and Cisco. They provide not only the services for some types of distributed development, but also for IoT control and for communication of the devices. Depending on the exact and specific plan, it's possible to find different level of support and level of security and amount of the resources available for the device. The paid plans provide an ability of a lot of connections per second for each device, but free plans typically support the limited number of connections of the device connected and the connections of each device during some period of time. Also, among the popular services, it's possible to name the following: Oracle IoT, Eclipse, Salesforce, IRI, Particle, and ThingWorks. But for the communication with the small devices in the community, the most popular platforms include the following set of platforms, starting from ThinkSpeak. This is popular service based on the MathWorks integrated with MathLab, and this is a default service for most of Arduino components because of the ability to work with the simplest chips with amount of the built-in memory near 1 kilobyte over GET requests, and it allows to use the centralized communication with the device even with for the lowest price chips. Another services are CAR, Zeta, DSA is completely model-based service, Device Hive, GE Predix, Home Assistant. Home Assistant is a favorite service for most open solutions, and if you want to build your own smart home based on the mass production of the devices and the sensors available at markets, you can start from the Home Assistant because it's supported by community and it's a very popular open solution. Next service, Open Connectivity Foundation, is based on the collaboration of different companies like Intel, Samsung, and so on. Open Hub, Open IoT, Open Remote, Open Thread, and Platform IO. Next slide, please. So, based on the considered ways of communication and diagrams that we provided with the communication of the services, it's possible to propose the following models of such devices that include the model of some data producer when the device is just the temperature sensor or water level sensor or something else. The device in this case produces some traffic, and the another point can perform the monitoring and telemetry of such information. In this case, the communication can be done even in one direction, and for the use of local data processing, it's possible to perform the use of some one direction physical interfaces. Second model is based on the two-directional communication over internet, and in this case, this type of devices allow some kind of activation, and it can be done like some event-based model where the sensor provides some information about action to the monitoring device and receives the required action to execute this action. It can be some smart valve, for example, when the element or sensor detects some changing of water level, and the activation logic can perform the blocking of or opening of such electronic valve. The third type of the model is a new type of the devices like active node. It's not the same as some coordinator. It's a new type of devices that includes the element of artificial intelligence and allows to perform the initiation of communication with another nodes without the actions from human, and it allows to perform some decision at this node. For example, the activation of some logic based on the calendar, time, date, based on the parameters of the system, like the battery level, and based on the external events. So this device, in this case, can perform the initiation of communication with another devices to organize some cross communication, like the next model. This model is close to the communication of the devices in ZigBee protocol, but it's closer to reorganization of nodes to perform the communication in case of the loss of connection between few nodes. And in this case, some node can pass the information directly from one node to another to recover or to allow the communication between different parts of the net with such devices if some parts of the net outside the range of connection to the internet. Next slide, please. So, based on the performance analysis, the following results are obtained. And the main results are the performance, the classification of the devices, the services for communication, the protocols, and the proposed models. We are ready to answer for your question, and for us, it will be a pleasure to answer for the questions. Please.
We finished.
No questions.
Okay, thank you. Colleagues, any questions, please? Okay, I have one. I saw that, as I understood, you combine different devices for costs, principles of working, etc. Did you or do you take into account where these devices were produced in China or in other countries, taking into account geopolitical system? Maybe may occur some problems in these components. Are they from Chinese or they are even Ukrainian? That is a question.
Based on the analysis, it's possible to conclude that the second and third items in this list can be produced at any place, including China. But the first type of the device and last two can be produced at any country. And of course, we know our production of some installations and this type of device, of course, producing in Ukraine, and the exclusive professional devices also, but it has too high price. But only the end user and maybe the company that performs the localization of the IoT systems use exact devices, and the decision of the choice of such devices is based on some rules and maybe requirements to security for the exact applications. And depending on that, it's possible to select the country of origin of such devices or prototype the required devices. Or even it's possible to order the development at the exact country some devices based on the model. I mean that it's possible to perform the ordering of the production of some part of the devices, maybe up to few thousand of elements.
Okay, thank you. Thank you for your answer. Dear colleagues, any questions? Yeah, please.
So I have a question. How how about security, maybe cybersecurity of your system?
The cybersecurity is one of possible consideration and one possible requirement for the end system. The main idea of our research was focused on the services, and dependent on the requirements again to the cybersecurity, it's possible to select the exact service for communication. If the required level of security, updates of the system, and so on is required, it's possible to choose the paid plans from well-known companies like Watson IoT, for example, because this company provides the highest level of cybersecurity. Yes, this page, please. And it provides an ability of support, online support at any time, and provides the ability of updating of both devices and the service itself. So if such requirements are valid for the system, it's possible to use the paid accounts. But again, the free version of Home Assistant is securely enough for all non-critical applications, for home application and so on. And if there are specific critical requirements for the solutions and for installed versions of the system, it's possible to use well-known companies mentioned as magic corporations.
Okay, thank you. Any questions? Okay, let's move on.